This is lesson 6, metals in the extraction booklet, pages 30 to 37 on the blast furnace. So we start on page 30. You can come back to this once you've looked through all the slides on this PowerPoint and watched the video. So extraction of iron metal in the blast furnace. So we're looking at how we get iron. Basically, you've got the blast furnace like this. You've got raw materials going in at the top, and the raw materials are the iron ore, so the rock that contains iron, limestone, and coke. Not Coca-Cola, it's charcoal like coal that goes in the top there. And as you can see, the temperature increases as you come down the blast furnace. And out at the bottom here, you make the molten iron, which is very, very hot liquid iron. You also make a byproduct or a waste product, which is called slag. Now this is made from the impurities from the ore and the limestone reacting together, and there is a use for that byproduct as well. So there's just another diagram showing you the same thing. You have to have hot air going in because everything's burning in there, so you need the oxygen. Limestone gets rid of impurities from the iron oxide, which makes the slag, which is the byproduct, and that should read from, so apologies for that. There's another diagram here. You might see the word toyers. Toyers are like pipes that will blow the air into the blast furnace. I'm hoping I'm saying that in the right way, but if you see that word, it just means they are pipes that blow in the hot air. So you can have various diagrams of the blast furnace, and you need to label one on page 31. So what happens in the blast furnace is the coke, which is carbon, burns in the oxygen to make carbon dioxide. Then this burns in more carbon to make something called carbon monoxide, like CO, which then reduces the iron oxide to iron. The blast furnace is brick-lined because you can imagine the high temperatures, they could get burnt away, and they do, but they last longer than most things. Now, when the iron comes out of the blast furnace, and you can see it being poured out here because it's molten iron, it's called pig iron or cast iron because it's very, very brittle. So it needs to be moulded into the shape, and it stays in that shape. It can't be hammered into another shape because it's too brittle. It was sometimes called pig iron because you can see the piglets there feeding off the female pig, and the rivulets there of the molten iron coming out years ago, and it looked similar. So you might see it referred to as pig iron or cast iron, but cast iron because it's got to be put into moulds and it keeps the shape. So cast iron uses: railings, frying pans, old frying pans, and drain covers. These aren't the new aluminium or copper frying pans. These are the cast iron frying pans that you make Welsh cakes, skillets I think they're called. And there are some cast iron pipes there that will keep their shape, but they're moulded into that shape. You can't hammer them, and they're not malleable at all. So the slag, which is the byproduct, can be used in road building. It can act like a foundation for road building, and you can put it into little chippings like that. And the hot waste gases are recycled to go back into the blast furnace, so you're not wasting heat. So complete the pages 30 to 37, but also watch Fuse School Extraction Using Heat, and that's the link for it. But be careful because they do say that carbon dioxide is CO3, and we know that it's CO2, so there is a mistake in that. So you're filling in all these pages. You've got some labels to add to that. You've got to link these up, matching the raw material to why it's needed. You've got some questions all the way up to page 37 once you've watched the video and gone through this PowerPoint.